The next thing we are looking at is what? The derivative of cosine, which means that when we differentiate cos of the angle x, what are we going to get? So we are going to derive this derivative of cosine using what? The first principle. So you know that the first principle is given as this. So what we are going to do here is to identify our f at x and then our f at x plus h. So we can say that our f at x is given as what? Cos x, and then our f at x plus h is going to be what? Cos of the angle x plus h. So the next thing we are going to do is to substitute this back into the first principle formula. So we are going to get the limit as h approaches 0 of cos x plus h, and then we have minus cos x, and this is all over what? H. So you all know that when we take the limit here, we are going to get cos x minus x all over what? H, and this is going to give us what? 0 over 0, and we don't want it in that very form. So what we are going to do here is to employ a compound angle. So we are going to use these compound angles to expand these very parts. So we are going to get the limit as h approaches 0 of cos x cos h minus sin x sin h. Then we are done with this. Then we move on to minus cos x, and this is all over h. So the next thing is to do a little bit arrangement on the top by bringing the negative cos to this very part so that we can factorize the cos out. So we are going to get the limit as h approaches 0 of cos x cos h minus cos x. Then we have minus sin x sin h all over h. So we can see we have cos x here, so we can factorize it out. So we are going to get the limit as h approaches 0 of cos s out. We have cos h minus 1. Let's give the h to these very parts, and then we have minus, okay, let's take the limit so that it will be faster. The limit as h approaches 0 of sin x, and then we have bracket sin h. Let's give the h to this very part. So from here, when we take the limit, you know that the limits of cos x as h approaches 0, we are going to get cos what? X. And we know that from our basic knowledge and the limits of functions, the limit of cos h minus 1 over h as h approaches 0 is what? Is 0. Good. And then the limit of sin x as h approaches 0, we are getting what? Sin x. And this, from our prior knowledge on limits, we know that this is going to give us what? 1. Good. So cos x times 0, we know it is 0, and then minus sin x times 1, we are getting minus sin x. This means that the derivative of cos x is negative sin x. So we have negative sin x.